Welcome to another YOUnite video, and let's take a look at a use case because use cases are great for showing how things work. And here we want to show how the different types of data in the IT ecosystem work with master data management. And you might want to review the short video we've already built called Types of Data in the IT Ecosystem before we get started, or you can try to follow along and I'll give a little background on the types of data as we go. Just searching the internet, you're going to see many different ways or perspectives on how to classify data. And it could be just simple classifications like strings or integers, or you get into these more high-level or more abstract descriptions. And you can look at Gartner, and I've even seen some by Forbes magazine to help professionals get their head around data. And in our experience, we find it easiest for the data stakeholders that are taking on master data management initiatives to look at data as fitting into one of three categories. We'll do a real quick review here. Number one, you have structured data. And this includes a subset of the data in your relational databases or well-defined object stores that need to be synchronized between multiple systems. And it's often easiest to think of these as the nouns in your data sets. For example, customers, employees, bank locations, ATM machines, things that generally are very critical for the business in and of themselves. And that can be contrasted with number two, transactional data, because this data is often stored in relational databases, but probably more frequently in object stores. But these things are often seen more as verbs or events that are being generated by your nouns in the structured data. These generally aren't synchronized unless it's just like you're doing some bulk copy, like a copy to a data lake or a data warehouse. For example, a bank may have sensors that are regularly checking the status of their ATMs, and that data might be sent, stored, then analyzed, and then some reports may be generated. And the raw data is generally archived to a data lake or something like that. So we have our structured data, our transactional data, and then we have our unstructured data. And these are blobs. For example, PDF files, images, videos, Word documents, Excel spreadsheets, those kinds of things. And the boundaries between these three types of data aren't really rigid, but there's generally a consensus among the stakeholders of how things get classified. And if there isn't a consensus, it's something that needs to be addressed as you're planning your MDM initiatives. But a good use case can kind of cover this. So that's what we have here. So let's get started with our use case. And let's say our bank keeps a picture of their customers as part of the bank customer record. So customer records are structured data. These are clearly nouns and important data records that we want to synchronize and replicate between systems. This information, such as customer name, social security number, home address, et cetera, but it also has a picture, which you may think is a blob or unstructured data. But it is unstructured data, but it can be tied to the structured data, so it becomes part of the master record for the customer. And you could make a case that you could have structured data that is completely comprised of references to unstructured data. But there's usually one or more text or numeric data fields or metadata that act as the key or ID for a master data record. And if we were to boil it all down to the pure science of structured data or master data, these keys and IDs are what are used to uniquely identify the structured records. Now let's continue on with our use case and say that there are a number of ATM machines for our bank that are regularly sending streams of information back to the bank about its status, including video feeds that it takes as any type of motion is detected in front of the ATM. And this would be considered transactional data, since generally this data is not going to be synchronized between other systems. You might be replicating it, but you're not going to take every one of these events and treat it as a master data record. And so these video feeds that it takes every time there's motion detected would be maybe archived to a AWS S3 bucket. And the results of these streams can be joined with the master data about the ATMs. And so the reports reflect the latest information about the ATM, such as last service dates and the ATM model and things like that. So like any bank, customers visit their ATMs and perform banking transactions such as withdrawals. And even though we call these transactions, these are really a critical part of the bank's business. It would be considered structured data or the nouns and things we'd want to synchronize using our master data management platform. So this is master data. Now let's imagine that a customer finds an ATM transaction on their statement that isn't theirs. So they call the bank and are transferred to the security and fraud department, and a fraud ticket is opened up. Again, this is an example of a noun, this fraud ticket, since it's structured data that needs to be replicated to other systems. A bank security analyst looks at the fraud ticket and creates a security case and begins the research by extracting video images from the ATM motion sensor's S3 bucket in the minutes before the fraud was committed. They may copy these from the S3 bucket to a shared Dropbox folder. They also will pull down the customer's profile photo and any images or videos taken during the ATM transaction. So now we have unstructured data sitting in a folder inside of Dropbox. The security officer looks at the image and thinks the customer is mistaken and actually made the withdrawal, and also uses some machine learning tool to confirm with face recognition and the geometry and all that the person making the withdrawal at the ATM and the customer are in fact the same person. So the security officer contacts the customer and describes the clothes worn by the person performing the ATM transaction, and the customer recalls the transaction and acknowledges that it's their error. But now let's say the security officer gets immediately pulled off onto some other task and doesn't have time to properly close the case out. Now there's some images and videos, the unstructured data, sitting in a Dropbox folder, and possibly some other images and videos in the facial recognition system. And perhaps these file systems where these images and videos are temporarily stored have permissions wide open or open to partners and contractors or some subset of the people in the company that shouldn't have access to them. But the security department has some security software that works with unstructured data that allows imports of master data and scans all unstructured file shares for images and text that could compromise the customer or the company, and automatically file security tickets when it matches this model. So, we could go on, but I think that's a pretty good example of showing how all of this ties together and how we need to leverage the master data and understand what the master data is and how it works with your unstructured data and your transactional data. So we'll be posting more of these. I hope you found this useful. If you like it, give it a thumbs up. If you want to find out more about YOUnite, just look at some of the other videos here or contact sales@younite.us. And thank you very much for listening.